In this video, we're going to look at the photodiode. It's right here. You can see how much current's going through here. Not much, and that's because the light is not terribly bright. I'll get my flashlight here, and we can increase the amount of current. We do have a 100 ohm resistor right here that is going to help limit current. Also, we are only using 1 volt of power, or 1 volt of potential, I should say, at the moment. And so, the photodiode, it looks like an LED. It does not light up though if you pass current through it. And so we have it reverse bias. Long lead the anodes to this jumper that heads to the negative rail. Short lead the cathodes to the resistor, which heads to the positive rail right there. And the amount of current is actually at this point based on the light dependent, or the photodiode I should say. I almost called it a light dependent resistor. It is a photodiode, and it doesn't work on the resistance principle. It works more like a current source. And so the jumper here is going to go directly to the positive rail. So as long as I don't bump the photodiode, we should get pretty much the exact same current right there. And I think it might be a speck higher because it gets warmer, but for the most part it's the same current with the same amount of light falling on it. So there is a 100 ohm resistor, and pretty much spot on. And I also have a 1 kilo ohm resistor, 1000 ohm resistor right there. So we have the same current, but now if I put the bright light on there, we have more resistance. So we're going to get about 1/1000th, because as I said before, we're only dealing with 1 volt of power. And so we're going to zoom back again. This is based on how much light is falling on it. And so, of course, we can also go the other way. We can lower the current. So there it says 0 milliamps of current. I'll put this to microamps. So it kind of looks like a U. That is actually called mu, but it's for micro, 1/1,000,000th of an amp. And there you can see we can get it down to 0. If I get it dark enough. This is a cover for an alligator clip right there, and it works pretty good for covering the photodiodes and the light dependent resistor. So in any case, there you can see the current depends on the light. So we're using 1 volt, and usually we're dealing with Ohm's law. Let's get back to milliamps. I think we proved our point in microamps, and we don't want to run too much current through the meter. So there we have 0.51 milliamps of current with this amount of light. And so I will raise the voltage. There you can see it looks like the component's getting warmer, and so it's passing a tiny bit more current, but it's what's limiting the current, not so much the resistor. And this one I think is still the 1 kilo ohm resistor. So we have 5 volts. We can expect a little less than 5 milliamps of current, because it looks like the photodiode has a little bit of resistance. It doesn't become quite a perfect conductor, but pretty close. If we take the resistor, it's a 1 kilo ohm resistor, and bypass it, there you can see 5 volts across a 1000 ohm resistor, 5 milliamps of current. And so I just put it to that jumper to measure that. So the photodiode is what is limiting the current. So I won't want to do that while the jumper was on there and put a bright light on there, because we'll probably exceed the wattage rating of the photodiode. So I have the resistors to limit that. So I have the 1 kilo ohm right there. We can go up to 10 volts, and perfectly fine, and passes. We're still within the wattage rating right there. Now we're only limited to about 9 milliamps of current if I get the light right, and for some reason I'm not right now. Oh, the flashlight, I changed the brightness of the flashlight by accident. That was the problem. So there we go, a little less than 10 milliamps of current. Of course we can get more current with a 100 ohm resistor, but 10 volts across a 100 ohm resistor is too much. So we're going to turn the voltage down to 5 volts. And this is actually the maximum wattage for a 100 ohm resistor. Without the photodiode at all, we would get 50 milliamps of current across just the resistor, and that would exceed its wattage rating. But even with the photodiode, there you can see we're falling a little bit shy. I think it's because it has some resistance, even when it's technically fully conducting. But in any case, there you can see we're still pretty close to about 50 milliamps. And yeah, that looks like that's the brightest setting for the flashlight right there. But in any case, it's pretty cool. The photodiode is basically a light dependent current source for the most part, and you can get it to conduct fully pretty easily, just like a light dependent resistor can get its resistance down. But with the light dependent resistor, it actually has a resistance, kind of like these fixed resistors. So we already looked at, I can move the voltage of the power supply and current's holding steady, other than it gets a little bit, goes a little bit higher because it's getting warmer, has to dissipate more power. And but with the resistor, I'm going to do this really quick because it'll be at its maximum wattage rating right now. There you can see, for some reason we have we have current limited at the power supply. That is the problem. So we're at the absolute maximum right now of what the current will go, plus what the resistor's wattage rating for. We're at the maximum. Looks like it's falling a little short because there's a little resistance in the wires. The meter might be providing a little, and that might be slightly higher. So I'm bypassing the light dependent resistor right now, and I'm going to turn the power off because that resistor is probably pretty hot right now. But hopefully it cooled down enough to touch. It's really fairly hot now, but not too bad. There we go. And now we will turn the power. Hit the wrong button. There we go. Turn the output back on. So that is 0.55 milliamps. Now if we get light on there, it should get a bright enough light, about 50. So yeah, it looks like resistance still limiting us a bit. And also, you can see how much current, for the most part, you're getting on there, but not when it gets down to the microamp range. So, in any case, just kind of quickly threw this together. I think I covered pretty much everything I wanted to. So, hope you enjoyed. Thanks for watching. I'll see you in the next video.